So, good morning, everyone. In the last class, we have seen the concept of graphical representation of data. Before that, we have learned how to arrange the data in a tabular format, where we have seen many types in which the first was raw data, second was ungrouped frequency distribution, then came grouped frequency distribution, then finally we got with continuous intervals. In that, we had exclusive and inclusive. Now, let's see the graphical representation. Bar graph we have already discussed. In this example, you can see it is actually these rectangles which are showing the data in a particular month. So this is an example in which I think there are 40 students were asked about their date of births. Okay, and what they have done is they have counted the months for them. So there are three students who have birthday in January. There are five students who have birthday in May, and that way they have arranged and made a bar graph. So you can see in bar graph this thing which is coming on the independent axis, that is the x-axis, is normal data. It is not continuous. Simple value is there, like the first bar is showing January month, second bar is showing February month or something. So it is a fixed value, not a group or not a class interval. You can see this thing. And on this axis, y axis, we are having the variable part, that is the number of students which is changing. So I hope this part is clear to everyone of bar graph. Please confirm. Bar graph we have done earlier also. So I hope this is clear to you. The main thing that you have to keep in mind is in this we have rectangles of continuous width. You can see the width of all these bars is fixed. You can't change this width. So first thing is width of the rectangles, and second thing is the spacing. While you are making a bar graph, you have to take care of the spacing. This spacing should not be disturbed. Okay, it should be same all throughout. So we have written over here all bars or rectangles are having same widths but varying heights and equal spacing or gap between bars. So this we have done, and observation is there also that in this independent axis is having no grouped distribution. There is no class interval. Simple values are there. Let's see one more example. A family with monthly income of rupees 20,000 had planned the following expenditures per month under various heads. So again you have some heads in front of you but no class intervals. So grocery expenditure is 4,000 rupees, rent expenditure is 5,000 rupees. So in that way you can again go for a bar graph for this data. So you can see simply they have made a bar graph with equal spacing. You can see the spacing between the bars is equal. Second thing, all bars are having same width. It is not like that you can make one bar this much thick and second bar this much. This will be wrong. Okay, so you have to use uniform width bars with equal spacing between them. That's it. Okay, now comes the next topic, histogram. As you can see, they are saying how a frequency distribution table for continuous class intervals be represented graphically. So for that, we have the topic histogram. So class, we have earlier also seen the topic histogram. This time we will just increase it little bit. Okay. For definition part, we can take from book only. I think it is somewhere here. Hmm. Okay. So you can see it is here. Yes. So histogram is a graphical representation of a group frequency distribution with continuous classes. So you have to make sure that the classes are continuous. This graphical representation is for continuous classes. So in case classes are not continuous, you have to make it class. If in case the data given to you is inclusive, that means you have to make it. Before making a histogram, you need to keep this in mind that the class interval should be continuous. So in case the paper gives you inclusive representation, you have to make it exclusive. And we all remember how to make inclusive data into exclusive just by using the same method of Hill approach. You have to see the gap, whatever gap is there between the upper limit of one class and lower limit of second class. Vaishnav, in bar graph, I have told you there is no concept of these class intervals continuous or something. They are simply using some fixed values on the x-axis. You have seen in this there was no range at all. In the bar graphs, we have simply grocery. Grocery is not a range or something, na? We don't require that thing. So grocery, rent, education, medicine, fuel, entertainment, and miscellaneous. That's it. So whatever you use in this bar graph, the x-axis will have independent variables and those are not having any class interval. I hope Vaishnav it is clear to you. Hope Vaishnav please confirm. We are only using fixed things in this x-axis, okay? But in histogram we are bound to use exclusive class intervals. So class please confirm, is this one exclusive or we have to make it exclusive? Please tell. Is this exclusive? Yes, it is exclusive because you can see that the upper limits and the lower limits are same, so it is exclusive. Class, tell me one more thing. Is the width of all class intervals same? And if same, what is it? Please tell. Is the class width of all these intervals is fixed? And if fixed, what is the value of that class width? Yes. You can see in this given data, it is fixed 5 all throughout. So in the case of bar graph, there was no concept of width because it was fixed throughout. In any bar graph you take, the width of the bar has to be taken same only. Okay, there was no such concept how much width you have to take. But in the case of histogram, it is very much critical to understand the width of all the classes. I will tell you there are two kind of histograms based on that only. Let's see. So till now we have got the first point under histogram, that first thing required is continuous class intervals. To make a histogram, we need a continuous class interval. Second thing is they are saying also, unlike a bar graph, that means it is little bit different from bar graph. How? The width of the bar plays a significant role in its construction. So class, as I've told you, the width of the bar plays a significant role. That means you have to take care of the width also. So here width are of two type. Either it will be uniform throughout or it will be non-uniform. So width of class interval should be taken in consideration. Interval. Either width will be uniform or non-uniform. Uniform means all width same. So in this case, some are some or all are different. So first case, as usual, we will take the ideal case when all the widths are uniform. and we will understand what is the logic behind this thing, why we are changing this thing. Okay, we will see why this width is important for us. If you have read these concepts, as I've told you, you would have got this thing earlier also. Let's see. Here they are saying the area of rectangles erected are proportional to the corresponding frequencies. Class, this is the reason behind width. In the bar graph, we were not taking into consideration the width of these rectangles, but in histogram, these width are important. So the reason behind point number 2 is areas of rectangles in histogram should be proportional to their frequencies. Anyone who understood this thing? What do we mean by this? Simple meaning of this thing is, if there are two bars like this, suppose this is bar number 1, this is bar number 2 in a histogram. Okay, don't confuse with bar graph. I am just telling like this. Okay, let me call it rectangle. So if you have rectangle 1 and rectangle 2, yes beta, area is not equal, Vaishnav. Don't say that thing, not equal, but proportional. Yes, if frequency will change, width will change. Okay, that way you are saying. Utkarsh, that is not correct. Okay, it will be correct. Don't worry. Just see one thing. Just see one thing. What it means. Why we are saying area of rectangle is proportional to the frequency means, if you see this first rectangle and if you see the second rectangle, who has more frequency? Please tell. Amongst 1 and 2, which rectangle is having more frequency? Rectangle number 1 has more frequency. That means the area also should be more in. If one has more frequency, then its area should be more than 2. This is a concept, or this is the meaning of this third point or the third condition of a histogram, that areas of rectangle in histogram should be proportional to their frequencies. So if frequency is saying that 1 is more than 2, then area should also say the same thing. Class, if you see area of this rectangle, what it will be? Please see. The length part, if you take, it is around 9. So we can say this first rectangle has length of 9 and breadth of how much? 5. So the area is 9 5s are 45. Suppose square units, whatever the unit is, it is square units. What is the area of second one? It is 6 into 5, 30. Very good. The third rectangle area is 14. I think it is 15. Yes, 15 into 5. So you can see, class, just tell me one thing. Is this histogram correct? Because the conditions were, first you should have a continuous class interval. We have. The first condition is fine. Second condition was the width of class interval. We have to see, in this case it is uniform, so nothing we have to do. In uniform width, everything is fine. Why everything is fine? Just see. You can see this 5 is actually not changing anything in the area. This 5 is fixed for all. So obviously we will get the area proportional to this frequency. Class, we have got this thing, area is proportional to frequency. It is a condition. Area is given by length into breadth proportional to frequency. So in the case where width is constant Do you think this breadth will change anything? Please tell. If already the breadth is constant, we can say that length will be proportional to frequency, and that we require only. So in this case, we don't have to change anything. When the width is uniform, everything is fine. This is a correct histogram. No changes are required. You just need to make it as it is. Please tell me, are you able to understand this point or shall I repeat this? Please tell me, are you able to understand this thing? Okay, Piyush is saying repeat. Fine. One second. Piyush, it will be clear as soon as we will do the next part, because right now you are saying the correct case. So just we want to say one thing. Fine. Hmm. So there are three conditions for a histogram. First is you should have a continuous class intervals. If you don't have, you have to make it. Okay. First condition is clear. Class, please confirm. First condition is you should have continuous class intervals. If you are having inclusive one, you have to make it exclusive using the ways we have learned before. This is the first condition. The second condition is the width of class interval you have to observe. You can't just make a graph and go to the next question. You have to see what is the width. Is it uniform? That means same throughout, or is it changing? So in the given example, the width was same. Now question arises, why width is important? Class, Piyush, the question arises why this width is given this much of importance. The reason behind that is the concept third one, that in a histogram, we should have areas of rectangles proportional to their frequency. That means if one rectangle has more frequency, it should have more area also. They should be proportional. अगर एक चीज ज्यादा है तो उसकी frequency ज्यादा होगी. That means if I am comparing third rectangle and this is fourth, this is fifth, and this is sixth. If I am comparing third rectangle and sixth rectangle, then obviously it is having more frequency. It is having, this is a symbol for frequency. You will study in physics. Okay. If you don't want, you can just write like this also. More frequency, less frequency, then their area should be similar, like this. Their area should be more also, less area. Now, Piyush, is my point clear? You have to make sure that these three conditions should be met by your histogram. Then only the histogram is correct. Now let me show you why the problem will arise. So in case number 2, if width are not same, what will happen? Let just me show you. So in this case we have seen the rectangle which was having more area was obviously having more frequency also. Okay, the reverse we have to say, the rectangle having more frequency was having more area also. You can see this rectangle was having the maximum frequency 15, and the area also is maximum of this rectangle. So our condition is being met. But in this example, first of all, just tell me, is this exclusive or inclusive? Tell me, is this given data exclusive or inclusive? Class, all of you, please participate. Just tell me, the given data is exclusive or inclusive? This is exclusive, because we can see again the upper limit of first class and the lower limit of succeeding class is same. So this is exclusive. Very good, Garima. Now tell me about the width. Do you find the width of all class intervals similar or different? Yes, Utkarsh. Not different width. We will change the frequencies. Utkarsh, we can't change the width on our own. Okay. So this is a non-uniform width. You can see the width in this case is how much. Width is found by the formula upper limit minus lower limit. So width. Let me make one more table to understand this thing. This time width is having some sort of what you say interference. So width is 20 over here, width is 10 over here, 10 over here, 10 over here, 10 again, then this is 10 again, and this is 70 and above. The example is in an examination, out of 100 marks are given, that means the last one is 70 to 100. So what is the width? If the last interval is 70 to 100, the width is 100 minus 70, 30. So what we have got is only two intervals are changing the width. And now in our area, you have seen in the last question, area is given by length into breadth. We showed length by frequency and width by breadth. In the last question, the breadth was having no significance at all. In the last example, breadth was not having any significance because it was same. You can see in this example, breadth was having no say. Breadth was same as it is. So only frequency was responsible, and therefore we were not looking at anything. We were just happy and we finished the work. But now this breadth is also having equal say in this histogram. And let's see how it changes the conditions. Just see. This is the first bar we are having, or the first rectangle. This is the second rectangle. As you can see, frequency of second rectangle is more than frequency of first rectangle. Our condition is if frequency of second is more, its area should also be more. Let's try to find area of first rectangle. Class, please help me. What is the frequency of first rectangle? Please tell me. Please tell me. The frequency is 7. Very good. And what is the width of this first rectangle? The width is, yes, 20. The answer is 140 square units. Let us find now the area of second rectangle. Please tell me what is the frequency of second rectangle and what is the width. The frequency is 10 as well as the width is 10. So we have got 100 square units. So are we having the same thing? No. This time it is changed. Area of second is less than area of first. This was the significance. Your area of these histograms bars should be proportional to frequency. So can we say this histogram is correct? Please tell. Can we say? No, this histogram is wrong because the third condition it is not meeting. So we have to change something. Now the question arises, can we change the width easily or the frequency? And this question will be answered in our next class. So to be continued. I request you all to go through this concept, go through this example and try to understand, and let me know tomorrow also why we are changing one thing and why not the second one. Okay, either we have to change the width or we have to change the length, that is frequency. You have to see which one is easier to be changed. Okay, tomorrow you have to answer me this question. Now let me stop this, and please remind me also in the next class that I have to ask this question. So stop recording.